Hello, pre-calc. This is the weekend edition where you will learn the inverse of a matrix. What pops up into your thought cloud is, well, I know what an inverse is, so we'll grab Adam's thought cloud. Well, so if you had a 6 and you multiplied it by its inverse, you get a 1. So what number would that be? The multiplicative inverse of 6 is 1/6. So we're trying to do something like that with matrices. So I'll take 1, -1, 4, -3, and show you how to get the inverse of it. You probably had this before. You're going to multiply it by some matrix, that's what I want to know, and it's going to come out to be 1, but in matrix land that's 1 on the main diagonals and zeros everywhere else. So that's the identity that we want. So let me show you a method for doing that. So I'm going to take this matrix, 1 minus 1, 4 minus 3, and I'm going to put it together with this matrix. Only square matrices have inverses, and I'm going to take this square matrix, this 2 by 2, and put it together with this square matrix and create a 2-row, 4-column matrix. Now I'm going to use the row operations that we learned to make this look like this. So now it's 1, -1, 4, -3. I want it to be 1, 0, 0, 1. And as I use the row operations to create that here, this will change. And that will be the inverse when I'm all done. So let me show you what I mean. So let's say this is already a 1. So we got that. This has to be a 0. So I'm going to add row 1 plus row 2. And I'm going to replace row 2. So the 1, 4, 1, 0 in the first row won't change, but I'm going to add these two together. Remember the 3 operations you can do. You can exchange any 2 rows, you can multiply any row by a number, and you can multiply a row by a number and add it to the other row, replacing that row. So that's really what I'm doing. I'm multiplying row 1 by 1 and adding it to row 2, replacing row 2. So I'm going to add these 2 numbers basically. Alright, so now I see I have a 1 and a 0, I have this 1, I only have to change this to be a 0. So the way I do that is I take row 2, multiply it by -4, and add it to row 1, replacing row 1. So this time, when I rewrite the matrix, I'm going to put in row 2, unaltered. Well, -4 times row 2 plus row 1. -4 times this plus that. -4 times this plus that is a -3, and -4 times this plus that is a -4. Alright, so I got to the spot I was looking for. By using elementary row operations, I moved this, I made this to look like this. And now my claim is that this is the inverse. So I'm going to put it up here and see if it works. So -3, -4, 1, 1. So going up here, let's see if indeed that is the multiplicative inverse. Alright, so we learned how to multiply matrices. So to get this column, or get that entry, it's in the first row, first column. First row, first column, 1 times -3 plus 4 times 1. It is 1. This is in the first row's second column. 1 times -4 plus 4 times 1, 0. Second row, first column, 3 minus 3. Good. And 2, second row, second column, 4 minus 3. Alright, it worked. So we have the inverse of this matrix. So if we call this matrix A, we would call this matrix A inverse. And we rewrite it with A to the minus 1. Alright, let's go ahead and do a 3 by 3 and we'll call it a night or a day. Let's say that the matrix I want to find the inverse of, remember they have to be square, so I'm going to graduate from a 2 by 2 to a 3 by 3. So there's the matrix that I want to find the inverse for. And here's my main diagonals of 1. And all the rest fill in with zeros. And I begin the same way. This time I've got to get this left-hand side to look like this. Alright, so I start by getting a 1 in the first column, which happens to already be there. So I want to change this to a 0. So I'm going to do row 1 times negative 1 plus row 2, and that will replace that one with a 0. So when I do that, row 2 will be replaced, but row 1 and 3 will be unchanged. So I'll quickly write those in. And now I will multiply row 1 by negative 1 and add it to row 2. Okay, check my work. So if any of those are wrong, they look kind of suspicious. I got 0, 1, negative 1, negative 1, 1, and 0 by doing that. So if there's anything wrong, don't do what I did. Just do it correctly and show me on Monday. Alright, so now I want this to be a 0. So I'm going to do negative 6 times row 1 plus row 3. To get that to be a 0. So row 1 and 2 are unchanged. So let me write out row 1 and 2. Alright, so negative 6 times that plus that. Negative 6 times that plus that. Negative 6 times that plus that. That's a 4. Negative 6 times, where am I, row 1? Negative 6 times that plus that. Negative 6 times that plus that. And negative 6 times that plus that. Alright, coming right along, I now have, hey, this is a positive 1 right there, so I don't know what that looks like on the screen. Alright, because that row wasn't even changed. Alright, so, and this is a 0, I gotta write a little more clearly. Alright, so now I want to remember the 1s. So there's the 1. So now I'm going to mess with the fact that there's a negative 1 above it and a 4 below it. So I need to make sure those are both zeros. So to work on that, what if I add these two, replacing row 1? Yeah. What if I add row 2 plus row 1, replacing row 1. Okay, I think that'll work. That's one of the operations. There's a couple choices. That seemed like the simple way. So I'm replacing row 1 So I'm writing 2 and 3 unaltered. Alright, so if I add this to this, I get a 1. If I add this to this, I get my desired 0. This to this, I get this to that, and that to that. Alright, so let's see what we got. Looks pretty healthy. Now I need to zero in on that. So row 2 times the -4 plus row 3, replacing row 3. Alright. So row 1 and 2 unaltered. Alright, -4 times this plus that is -4 times this, sorry, plus that. Yeah, because I don't want to lose what I've already gained. So -4 times this plus that, -4 times this is +4, and a -3 is a 1. -4 times that plus that, -4 times that plus that, and -4 times that plus that. Okay. Not too much more to go. I see that I have to work on these right here. So what if I add these two, replacing 2? So row 3 plus row 2, replacing row 2. So that will create the same thing on row 1 and 3. Try to write fast. Okay, so I'm going to add row 3 and row 2, replacing row 2. 0 plus 0, 0. 0 plus 1, 1 plus -1, -3, -3, and a 1. Okay. Hope I haven't made a mistake. There's only one element left, and if I add row 3 plus row 1, replace row 1, should be done. So let me write in row 2 and 3. They won't be changed. This is like a silent movie. Okay, so I'm going to add row 3 and row 1. So this plus this is that. Alright. Let's see. Any boo-boos? Well, I see one. I'm glad I did. -4 and 1 is -3. Okay. Alright, so now I have the desired matrix here on the left, and this should be the inverse. So let's plop it in the very beginning and see. Did I write that out very clear? I did it. Alright, so the original problem was 1, was that the original? 116, yeah. -1, 0, -2, 0, -1, -3. My claim is the inverse is -2, -3, 1. And -3, -3, 1. And -2, -4, 1. And I apologize ahead of time if I made a mistake in one of my calculations here. So I want a 1 along the main diagonals and zeros everywhere else. So a 3 by 3 will give us a 3 by 3. A 3 by 3 times a 3 by 3 will give us a 3 by 3. So let's see. First row, first column. -2 plus 3 plus 0. Yay! So that's right. So that's 3 plus 3 plus 0. Yay! Alright, this one, this entry is going to be first row, third column. 1 minus 1 plus 0. Good. And now this one, second row, first column. -2, 0, -2. Alright. This one, second row, second column. -3, 0, +4. Yes, that's where I wanted a 1. Over here, second row, third column. 1, 0, -1. -12, -6, -6, -18, -6. Wait a minute here. Third row, second column. -18 plus 6 plus 12, 0. Alright, that one worried me. 6 minus 2 is 4. Oh, wait a minute. This one and this one. 6 minus 2 is 4 minus 3. 1. It worked. Alright, so that's what you should get if this is the inverse. Alright, so that's how that works. And we'll actually finish up our new information Monday evening when you watch the last video with new information. And we'll be using the inverse of the matrix for a special purpose. So, till then, over and out.